These are the frequently asked questions for Algebra 2, and it is for section 14.3, day 2. I'm going to start up here with number 24, where it says, in triangle ABC, angle C is the right angle. Find the remaining sides and angles and round your answers to the nearest tenth. So for number 24, it says little a is 17, and remember the lowercase letter is always opposite the uppercase letter. So this little a down here is actually 17. And then C is 22, so here's my C value. Opposite that, C is 22. So now, what they want us to do is find the sides and the angles. So basically what they're asking us to do is called solving this right triangle, where you're finding all the information that you know. And the first thing that comes to mind here is, hey, let's just use the Pythagorean theorem and figure out what B is here. So for B, we'll take a squared, 17 squared, plus b squared, and set that equal to 22 squared. So let's figure out what we have for numbers here. 22 squared is 484. 17 squared is 289. And then we'd subtract 289 from both sides. So 484 minus 289. That gives us 195. And last but not least, we'd take the square root. And because this is a side length of a triangle, we're not going to use the negative here. So we need the square root of 195, and that is about 13.96424, etc. So if we round this to the nearest tenth, it's going to be 14.0 for the nearest tenth. So now I have all of the side lengths. And what I need to figure out is an angle. And I could actually figure out either angle A or angle B. I think I'll go after angle A by labeling the side opposite and the hypotenuse. And that's because those were the numbers that came with this problem originally. If I use what I already found for B and my answer is wrong, well then I'm going to get this second answer wrong too. So to avoid that, I just go back to the original information. And I think SOHCAHTOA, and as soon as I get to SO, I see, well, there it is, opposite and hypotenuse. So the sine of whatever we have up there for angle A equals 17 over 22. And then we have to use the inverse trig function in order to get that angle. So I am going to punch in second sine 17 divided by 22. We use those inverse functions whenever we need angles. And the measure of angle A comes out to 50.59943.125. So this will be 50.6 degrees. Now, every triangle has 180 degrees. 90 is already gone for angle C. So if I just take 90 minus 50.6, that will give me the measure of angle B. So 90 minus our little 50.6 gives me 39.4 degrees for the measure of angle B. So use the information that you have and then think, how am I going to get what's missing here? You always use the inverse trig functions whenever you're trying to figure out an angle. Now, let me get this erased so that I can work on the rocket science problem with you. Kind of cool to think, hey, you're learning a little rocket science, but it's not a big deal here because what we're doing is we're using some trig. So an observer on the ground at point A, so here's somebody at point A, watches a rocket go into the air. The observer is 1,200 feet from the launch point B. Now, well, I better put some fire or something coming out of my rocket. There we go. And it says as the rocket rises, the distance d from the observer to the rocket, so that's our distance d there, obviously it's going to increase, because the rocket is moving farther and farther away. And it says express the measure of angle A in terms of d. So we need to get that angle right there. And again, that's going to be inverse trig. So we're going to set this up saying the measure of angle A equals equals, well, we want to figure out what is it in the end. Well, I know this is 1200 and this is definitely the adjacent side, and then I need this d in there because it said expressed in terms of d, and that's hypotenuse. Thinking SOHCAHTOA, sine is not it. Oh, there's cosine, adjacent over hypotenuse. So the cosine of angle A equals 1200 over. All right, now what I need to do is use the inverse function of 1200 over d, and that will get me the measure of angle A. So back up here where I started writing all of this, that is our formula. So then B says, now use it. So if find the measure of angle A if D is 1500. So I will have to do the inverse cosine of 1200 divided by 1500. So second cosine 1200 divided by 1500, because we could reduce that, but we don't have to. The calculator will take it. And they want this to the nearest degree. So it is 36.869896765, so that's approximately 37 degrees. And that is the measure of angle A. Then, for C, it says, all right, well, what if it's 2000? Well, then we do the inverse cosine of 1200 divided by 2000. So, second cosine 1200 divided by 2000. And that's approximately 53 degrees for the measure of angle A. So they're just getting you to see, what's going to happen to that angle as that rocket ascends, as it goes up into the air. 26, 27, and 32, all dealing with the same thing. It says, sketch a right triangle with theta as the measure of one acute angle, and then find the other 5 trig ratios of theta. So, I'm going to pick one of these acute angles, put theta right there. And for 26, it says the sine. Well, sine is opposite over hypotenuse. So that means if here my theta is down here in this right-hand corner, opposite is going to be over here, so that's a 3. And then hypotenuse is going to be 8. And it says find the other 5 trig ratios. Well, to do that, I am going to need this side length right here. And I can get that with the Pythagorean theorem. So 3 squared plus x squared equals 8 squared, because in the Pythagorean theorem, you always put the hypotenuse in for c. So a squared plus b squared equals c squared. My 8 has to go over there. 9 plus x squared equals 64. And then we'd take 64 and we would subtract 9. So x squared equals 55. And then we'd have to take the square root. And unfortunately, that's all we can do with it. There aren't any perfect squares that are going to go into that. So this is the square root of 55. Now, they want the other 5 trig ratios of theta. So we already did sine. That was what they gave us. Cosine of theta, this was opposite, this was hypotenuse, and SOHCAHTOA, cosine uses adjacent and hypotenuse. So that will be the square root of 55 over 8. Tangent of theta is always opposite over adjacent, so that's going to be 3 over the square root of 55. Now, we can't leave that. We know we're not supposed to leave radicals in the denominator, so we need to multiply our numerator and our denominator by the square root of 55. So that'll be 3 square roots of 55 over 55. Not pleasant, but we don't have to do anything with it. That's the good news. Then we need the secondary trig functions, and that's going to be cosecant of theta. And you get that from flipping sine. So sine was right here. We need the reciprocal. That's 8/3. And then we need secant of theta, and that comes from flipping over cosine. So the cosine of theta was right here. I just need to flip that. So that's going to be 8 over the square root of 55. But again, we know we can't leave that, so we're going to multiply numerator and denominator by the square root of 55, and that'll give us 8 square roots of 55 over 55. And then cotangent of theta. And we'll just go back to tangent and we'll flip it. So 3 over the square root of 55 becomes the square root of 55 over 3. So secondary trig functions, just reciprocals of the primary 3 trig functions. Now, I will erase this so that I can talk you through the same type of thing for number 27. So number 27, again, you get to pick which acute angle. I'm going to put theta right there. And cosine, remember SOHCAHTOA, is adjacent over hypotenuse. Well, adjacent is right here, and hypotenuse is right here. So ADJ, HYP, that leaves OPP for that one, and I need to figure out what it is, and I'll have to use the Pythagorean theorem. So 7 squared plus, I'll just make it x squared equals 20 squared. 49 plus x squared equals 400. So we'll take 400 and we're going to subtract 49, and that will get us 351. And then we have to take the square root of 351. Again, just the positive square root. Now, I noticed 3 plus 5 plus 1 is 9. So that means this number is divisible by 9. So that will give me the square root of 9 times the square root of 39. And that will be 3 square roots of 39. So then I try to figure out, are there any other perfect squares that'll divide nicely into 39, and that's not going to happen. So as ugly as it is, that is our answer, and it is 3 square roots of 39. Now we need to find the trig functions. We know we're going to have to do some rationalizing in the denominator here. So we start with sine of theta, and sine is opposite over hypotenuse. So 3 square roots of 39 over 20. Cosine, already did that one. That was 7/20. So now we need tangent of theta, and tangent is opposite over adjacent. So 3 square roots of 39 over 7. Then we need cosecant, and cosecant is what you get when you flip sine. So that's going to be a little nasty. We're going to have 20 over 3 square roots of 39. So then we have to multiply the top and the bottom by the square root of 39, and we'll get 20 square roots of 39 over 39 times 3, which is 117. Yick. So we check and see, was there anything that's going to go into both 20 and 117 to help us out there? And the answer is no. Then we need secant of theta that comes from flipping cosine. Well, cosine was way up here, 7/20, so that's going to be 27ths, like that one, nice and easy. Then cotangent of theta is going to be flipping tangent, not so nice. That'll be 7 over 3 square roots of 39. We need to multiply the top and the bottom by the square root of 39. So we get 7 square roots of 39 over 3 times 39, which is 117. So not fantastic numbers to work with, but we don't have to do any additional math with them, and we can be grateful for that, right? Then number 32. Number 32, what you have to remember is, I know we say 0.35 a lot in math, but this is 35/100ths. So then you realize, hey, wait a minute, that's just another fraction, and if I reduce this by 5s, I get 7/20ths. And I realize I already did the math for that kind of situation. I already used the Pythagorean theorem on that. So you certainly could do an educated cheat here and say, all right, there's my theta. This time it's sine, so opposite is 7 and hypotenuse is 20. But we already did the math for this. We had 20 squared minus 7 squared. We took the square root, took a 9 out of it, and went through that process and got what we needed. We had the square root of 39, 3 square roots of 39 for that one. So there it is, just in a different side. That's all it is. So for number 32, we're basically going through the steps that we had to use already for number 27 as we do this. Now, let's do them. They gave us the sine. We need cosine. So we have opposite, we have hypotenuse, and we have adjacent. Cosine is adjacent over hypotenuse, so 3 square roots of 39 over 20. Then tangent of theta, opposite over adjacent, 7 over 3 square roots of 39. Well, again, we've quickly rationalized the denominator, or you can just go back to your work from number 27 and see where we had to do this one. So 7 square roots of 39 over 3 times 39, which is 117. Then we need cosecant, and cosecant is what we get by flipping sine. Sine was 7/20ths, so cosecant will be 27ths. And then we need secant. That comes from flipping cosine. Well, I'm not too happy about that, but that's going to be 20 over 3 square roots of 39. So we multiply the top and the bottom by the square root of 39, and we get 20 square roots of 39 over our 117 again. And then cotangent, we need to flip tangent. So I'm just going to go right back to that beginning one and just flip that one. That way I don't have to do any rationalizing of the denominator on that one. So that's number 32. Now, I believe that might be the list of all that I was asked for. So that should do it for 14.3 day 2.